Good morning, students. We are going to start with the new course, Water Resource Engineering. It is in the 7th semester of DBATU BTech. Okay. So, in the beginning, in this first lecture, we are going to see the overview of what is Water Resource Engineering. We'll see what is water. Everybody knows that, but we'll go in detail and we'll see this branch of or the course of Water Resource Engineering and how it is important in civil engineering. Okay, so let's start. Okay. Now water is the greatest source of humanity on this earth. Okay, we know all that. Everything, the human development in the recorded history has been totally dependent upon water. The early civilizations which came up on the earth were all near a source of water like river Nile, river Indus, and so on. Okay, now the earth is a watery place. Okay, 76% of the earth is covered with water, but just how much water exists on, in, and above our planet? Okay, so about 71% of the earth's surface is water covered. Okay, it is not 76%, is it? It is 71%. And but out of the total amount of water which is present on the earth's surface, the oceans hold about 96.5% of the water. That means almost all of the water on the earth is salty. Okay, only a small portion of water occur as groundwater, that is 1.7%. Okay, and in the form of glaciers and ice caps, that also only 1.7%. Okay, so adding this 96.5% saline water plus 1.7% groundwater plus 1.7% water in the glacier and ice cap, that means water in the form of snow. Okay, the total is 99.9%. Okay, the total water is 99.9%. Okay, and 0.001% is just in the form of air as vapors or clouds formed of ice and liquid. Okay, so if we see here the sources of water which we generally know, such as rivers, lakes, and streams, they hold about just about 0.99%. Okay, 0.99% of water or the fresh water is in the form of rivers or lakes. Okay, and we are almost all of the population of the earth is totally dependent upon this 0.99% of fresh water. Okay, now uh, before we see what is water resources engineering, we will see how water plays an important role in the world economy. Okay, the now all the world economy is directly or indirectly dependent upon water in some or the other way. Okay, now out of the total fresh water that is available on the earth, if we add water from rivers, lakes, groundwater, ice caps, okay, out of those total amount of water, almost 70% of that is used for agriculture purpose. Okay, to grow foods for the people, to grow crops for the people. Now next, fishing in salt and freshwater bodies is a major source of food for many parts of the world. Okay, if there was no water, there would be no fishing. Okay, now fishing takes place in both freshwater and saltwater, as we know. This is all just basic. Okay, we are preparing for the course here. Now, much of the long distance trading of commodities is transported by boats and ships through seas, rivers, lakes, and canals. Okay, now most of the cargo of the world, okay, the import export business as we call it, it takes place through the ships and boats through various countries. Okay, so it is also an important source of transportation. Now next, Large quantities of water, ice and steam are used for cooling and heating in industry and homes. Okay. So the water from the basic examples such as the water cooler we use inside our home to large and complex cooling and heating mechanisms in industry, all require water, ice and steam. Even the nuclear facilities, nuclear plants, they also require water for cooling. Okay. The water industry provides drinking water and wastewater services, including sewage treatment to households and industry. Okay. So this is also an important application, drinking water for the urban areas and wastewater services. Okay. And last, water, ice and snow are also central to many sports and other forms of entertainments. Okay. May it be swimming and other such sports and entertainment. Okay, so water has a very wide application throughout the world. Okay, uh, every work and every job in the world is directly and indirectly dependent upon water. That should be clear, and of course many of us know that. Now, what is water resource engineering? Okay, now we'll see some definitions. Okay, what is water resource engineering? It is one of the definition is it is the quantitative study of the hydrologic cycle, that is the distribution and circulation of water linking the earth's atmosphere, land and ocean. Okay, now everybody knows about the water cycle. It is also known as the hydrologic cycle. Okay, if the students don't remember it, just remember you have studied it in school. Okay, the water evaporates due to the heat. Okay, it goes above in the atmosphere and form clouds. Okay, afterwards the water falls from the cloud in the form of precipitation, rainfall, snowfall. Okay, and it returns back to the earth. That is nothing but the water cycle or the hydrologic cycle. Okay, so water resource engineering is the quantitative study of the hydrologic cycle. Okay, now one part of water resource engineering is we are going to study all the aspects of the water cycle, that is evaporation. Okay, transportation, precipitation, and also runoff and infiltration. All these parts, evapotranspiration, these terms some of you may not understand. We will study those in detail in this course. Now, other definition, it is a specific kind of civil engineering that involves the design of new systems and equipment that help manage human water resources. Okay, so it is a specific kind of civil, it is water resource engineering is a part of civil engineering that involves the design of new systems. Okay, we will design some new systems to help manage human water resources. Okay, may it be those which are required for our domestic purposes such as water supply for drinking and bathing and other things. Okay, and some part will require for the irrigation purpose, that is for agricultural purposes and so on. Okay, now what is the role of a water resource engineering? That is important. Okay, as civil engineers we should know what water resource engineers do. Okay, water resource engineers must create new equipment and system to increase the effectiveness and efficiency of water treatment and water resource management. Okay, so the water which we have available in nature, okay, those the sources of water, we should know how to manage those. And next is the, if we have to increase the effectiveness and efficiency of water treatment. Okay, the water which we have available now, we have to increase the effectiveness and efficiency, and we have to treat that water. A water resource engineering may then oversee the construction and implementation of these systems to ensure that they are properly assembled. Okay, a water resource engineer can also, after he designs the new equipments, he creates the new equipment, equipments and systems. He can oversee the construction and implementation of these systems and equipments to ensure that they are properly assembled. Okay, and after completion of those systems and equipments, the water resource engineer may manage the maintenance of these systems. Okay, they have to manage the maintenance. Okay, so these are some of the photos of what a water resource engineer is needed to do. After seeing at the image, you may not be able to recognize what they are doing, but after we study the course, we may be able to know what we are required to do as a water resource engineer. Okay, now we will see some applications of water resource engineering. So the first application is the management of the urban water supply. Okay, the water which comes through the taps, through the pipes, okay, in your house, okay, in cities, okay, in metros and towns, okay, the study of management of that water supply, okay, that is one of the application of water resource engineering. Next is the design of urban storm sewer systems, that is one of the application. Okay, the rainfall which occurs in cities, okay, not all of it is infiltrated or seeped into the soil. Some amount runs off through the concrete roads, tar roads. Okay, so we have to design sewer systems which can accumulate that water. Next is the flood forecasting. We should know the forecast for flooding which will happen in flood prone areas for the next months or next year or the next decade, okay, depending upon our purpose. Then application of fluid mechanics to water flowing in an isolated environment like a pipe, pump, or in an open channel like a river, lake, and ocean. Okay, fluid mechanics we have studied in the second year as hydraulics 1 and hydraulics 2. Hydraulics 1 was study of flow through pipes, and hydraulics 2 was study of flow through open channels. Next application is the design of hydraulic structures such as sewage conduits, dams, and breakwaters. Okay, now when designing hydraulic structures, okay, it is the job of a structural engineer, but while designing hydraulic structure, the difference is we have to take into account the forces of water as well, which you are going to store in the dams. Okay, next is the management of waterways such as erosion protection and flood protection. Okay, next environmental management such as prediction of the mixing and transport of pollutants in surface water. Okay, this is self-explanatory. Next is the development of hydroelectric power. Next is irrigation, that means we provide artificially provide water to the agricultural fields to grow crops. Next is the navigation, that means transport of ships and boats through the water. And last, these are the 10 applications of water resource engineering. Now the civil engineers play a very vital role in the optimal planning, design, and operation of water resource systems. Okay, so if you have to design a urban water supply or a storm sewer system, or whether it be hydroelectric power plant or an irrigation system, okay, civil engineer play a very vital role in the planning, design, and operation of these systems. Thank you.